Okay, who can raise their hand and tell me what they got for problem number 1? You have a bag of marbles, has 12 blue, 6 white, 20 red. We want to know what percent of the marbles is going to be blue, and you need to round your percentage to the nearest tenth. What did you get, Camry?
I got 40%.
Not 40%. Isabella?
I got 31.6%.
31.6% is correct. So we want the percent of blue. So our little category, our part, remember we talked about it being a part over a whole. Your is value, that is value is the part, which is going to be the blue. So we're wanting to know how much is the blue, what percent of it is blue. So that's going to be 12. Yeah.
Didn't you say round to the nearest tenth?
I did. She said 31.6.
Yes, then you're down to 6.
No. The tenth place value is 1 decimal place. The tenth. You got your decimal and you got your tens, your tenths, your hundredths. No, I want the tenth. Then the tenth is the farthest you need to go. Guys, you understand rounding to the tenth means that you can have a number in the 10th place. That's what rounding to the 10th means. Okay? Now, the of value is going to be the whole. So the whole is basically your total. So that means you have to identify your total by adding all the marbles together, 12 plus 6 plus 20, which is going to give you a total of 38. So there's our of. And then the percentage is the value that is missing. We don't know what that is. So when we set this up, it's going to be 12 over 38. And that's going to be equal to x out of 100, or percent out of 100. You then do your cross product, so you're going to do 38 times x, which gives you 38x. You're going to do 12 times 100, which is going to give you 1200. And then you're going to divide by that 38. So we'll divide both sides by 38, and we'll get that x is roughly, because you're estimating it, it's going to be roughly 31.6%. 31.6. The 6 is the 10th place value. When I round to the 10th, that means the farthest I can have my numbers written is to that spot. I can't go past that spot. That's what it means to round to the 10th. Camry?
I know what I did wrong. I rounded to the nearest whole.
Yeah, you got to be careful about that. Okay, so for problem number, Jess got 3 questions wrong on a 25-question test. What was her grade, Kalel?
12%.
That's not her grade. Cameron? 88% is her grade. What's your grade based off of? How many you get right. When we tell you a grade, so when you miss one, so for example, guys, on your homework, when you missed one, there were 20 questions, you got a 95%. That 95% doesn't mean, hey, you missed 95% of the test. It means you got 95% of the assignment right. So what is your grade? Your grade is based off of what was correct. So when we're talking about the part that we are focusing on is how many were actually correct. How many questions did she get correct? If she missed 3, then she got 22 of them right. Okay, what is her grade? Her grade is based off of the correct answers, not the wrong. So you got to be careful about that. Then you've got the whole. The whole is, again, based off of the total, which is the 25 questions on the test. And we want the percentage, which is the variable that's missing. So we're going to set the problem up as 22 over 25. And that's going to be set equal to x over 100. We then do our cross product. So 25 times x is 25x. Then we've got 22 times 100 is 2200. Last step is to divide by 25. And you're going to get that her grade is an 88%. Okay? You could have also done 3 out of 25 and gotten 12% and then subtracted the 12% from 100. That's perfectly fine as well, as long as you understood that it's based off of her grade that's correct, not wrong. Okay? Last problem has 2 questions. Number 3, 80% of the candy was eaten, so he ate 36 pieces. How much did he originally have, Robertson?
He originally had 45 pieces.
Very good. He originally had 45 pieces, so how much does that mean he has left?
9.
9. Very good. Okay, so again, the values that we have right here, we've got our percentage, so we know that our percent is going to be 80. Now you've got a total amount of Halloween candy that is missing. We have no idea how much that is. That's the whole. The whole is the value that's missing. The part is the amount that he ate. So how much he ate was 36 pieces. So when you set it up, you're going to do 36 over x is equal to 80 over 100. You'll do your cross product, so you're going to do 80 times x, which would give you 80x. 36 times 100 gives you 3600. Then you're going to go ahead and divide by the 80, and you're going to get 45. Okay, so that means he had a total of 45 pieces originally. The second question, how much does he have remaining? If you subtract the 36 that he already ate, you have 9 pieces left. So here's our 2 answers. 45 pieces originally, 9 pieces are remaining. Make sure you read all the questions that they ask you because you want to answer every single part. And if I wanted to have made this a more difficult question, I would have bypassed asking you how much he originally had and just focused on asking you how much does he have left. You would have had to still find out the original amount and then subtract it anyway. So you need to be cautious or mindful of the stuff that they're asking, okay? All right, let's go ahead and get into our percent of change problems. This is the second part to our new unit, is the percent of change. All right, so when we talk about the word change, we've talked about change before. We said rate of change. What operation do you think of when I say something changes and I want you to find that change? Say it louder. Subtraction. So when we're doing a percent of change, the word change means that you're trying to find the difference between values. How one value changes to the next, that change is a subtraction of those 2 values. So the percent of change, the formula that you're going to use for percent of change, it's very simple, and you only have to this is the same as the problems that you were doing before. You had to identify an is, an of, or a percent. It's the same thing with these. You only had to identify 2 values, one of them being whatever your newest value is, and one of them being your original value. So to find the change, you're taking whatever your newest value is going to be, and you're going to subtract whatever your original value used to be. Now, because I need to do that subtraction first, what should I technically put around new minus original to showcase that I'm doing that subtraction first? Camry? Parentheses. So I'm indicating that this has to be done first. I have to do subtraction first, new minus the original. Once I've subtracted, I'm then going to divide that answer by whatever the original value was, and then multiply that by 100. So it's new minus old, divide by old, times it by 100, that's your percent of change. If you wind up getting a positive percent of change, it means that you increased from one value to the next. If you get a negative percent of change, it means you've decreased from one value to the next. So let's write that stuff down. A percent of increase it's going to be a positive change. Or an increase from old to new. So the percent of increase means it's a positive change or a positive percent that happened. It's an increase from your old to your new. If you've got a percent of decrease, then that means it was a negative change. So you decreased from old to the new. All right, in 1970, the average price of gas was $1.30. And in 2010, the average price is $2.95. I want to know, what was the percent of change that occurred? What is the percent of change that has occurred? So all you have to do in situations like this is identify what is your original value, your old value, and what is your newest value. So who can raise their hand and tell me what value in this problem is considered to be the old, the original? Raising your hand, thank you. Glenn? $1.30. So $1.30 is the original value. What is the new value going to be then? Jonathan? $2.95. So now that we know this information, all we have to do is plug it in into our formula. So we're going to take our new, which is our $2.95, minus our old, which is $1.30. Then we're going to divide that by the old. So divide it by $1.30 and multiply that by 100. So again, the portion that you have to do first is that subtraction. You have to subtract those values. So what do we get when we subtract $2.95 and $1.30? What do we get when we do that subtraction? $2.95 minus $1.30. What do you get? Huh? $1.65. So we're going to get $1.65 when we subtract. So now all we have to do is take $1.65 and divide it by $1.30 and multiply that answer by 100. So when we do that, when we do 165 or 1.65 divided by 1.30 multiplied by 100, you're going to get a positive 126.923, and it's just going to keep going and going and going. So we need to estimate it. We'll say it's approximately, I mean, you could put 126.9, you could put 127. It just depends on what they ask you to round it to. I'm going to go ahead and round it to 127%. So it's roughly an increase because it was a positive, 127% increase. So again, the process is very, very simple. What is your original value? What is your newest value? Plug it into the problem. New minus old, divide by old, multiply by 100. Alright, just bought a DVD player for $280. It's now on sale for $220. I want the percent of change that's occurred. Go ahead and do this one on your own. Identify your old, identify your new, plug it into the formula. New minus old, divided by old, multiplied by 100. What's that? Yeah, go ahead and round to the 10th. Let me write that down then. Round your answer to the 10th. Alright, who can tell me what is the percent of change going to be here? Robertson?
21.4%.
Good, and it's a decrease, right? Because it went down. So you should have, when you subtracted, you should have gotten a negative. So you should indicate that it is a decrease of 21.4%. So let's take a look at that. Our original Our original value here is what she originally paid for it. She paid $280 for that. The newest value is the discounted price, the $220. So all you're going to do is plug it into the formula. New minus the original, divide by the original, multiply it by 100. So we have to do this new minus the original portion first. What's 220 minus 280? Negative 60. So we're going to get negative 60. We then have to divide that by 280 and then multiply that by 100. When you do that, you're going to get negative 21.4%, which means that it is a 21.4% decrease. It is a decrease. These are two different ways that you could write it. You could say that it's a negative 21.4%, or you could just say it's a decrease of 21.4%. Can I switch over? Okay. I will in just a moment. Not yet. All right, so if I have an original price of, we'll say $30, and then my marked up price afterward, here, let me just go ahead and sharpen yours right now. Go. My marked up price is going to be $37.20. $37.20. I want to know what is the markup rate. So this is part A. Part A, I want to know what's the markup rate going to be. And then for part B, using that same rate, if I know that I've got a $25 price item, what will the markup price be? Okay, so the markup rate, guys, is the same thing. It's just the percent of change. How did you change from your original to your marked up price? How do you change from an original to a discounted price? It's the same exact item, percent of change. So in this situation, what's considered to be our old price? The $30, right? So our original price is at $30. What was the new price? $37.20. Okay, so all you're going to do is just plug that into your formula. You're going to do $37.20, and then you're going to subtract the $30 Then you're going to divide by the $30, and then you're going to multiply by 100. So if we do $37.27 minus 30, what do we get? $7.20. So we're going to get $7.20 that we now have to divide by 30 and then multiply by 100. So if we do 720 divided by 30 and then multiply it by 100, what do we get? Huh? $7.20 divided by 30, multiply it by 100. You're not going to get a negative because there's no negatives here. Huh? 24. So that's the percent. 24% was the markup rate. 24% was the markup rate. So now if I know, hey, my markup rate is 24%, and I've got the following information here, who thinks they could tell me, there's a couple of different ways that you could actually solve for X. I want to hear, what do you think might be one way to set a problem up to solve for X? What do you think, Robertson?
25 plus 24%.
25 plus 24%, and like plug that into your calculator. Okay, so these are different ways. Let's talk about them. Let's write all the different methods down. So Robertson's method, I'm going to even put Robertson's name right next to it. He says that he's going to take 25 and he's going to add 24%. All right, so in your calculators, do you guys know where your percent buttons are? Okay, in case you don't know, so in this one, if he says 25 plus 24, the percent button is right here above the parentheses sign. Okay, so you'd have to hit second and then hit the percent button. And it should plug up as a percent and hit enter. And he says it's going to be $25.24. Okay, so let's see if that, we'll see if that works. Huh? You did. Now, in the black calculator is going to be different. So 25 plus 24, and then the percent sign for them is on top of the 2. That's right. So you'd have to hit second and then the 2 and hit enter, and that one gives you 31. So here's a problem. You got 2 calculators that you just did the same thing with 2 different answers. So do you think that method's going to work every time? No, because it depends on the calculator that you have. So let's go ahead and cross that method off. But it's okay. We're going to try things out. Let's see. What do you think you could do, Isabella? A cross product? Okay, tell me how you would set it up. Okay, so she says maybe we could do the cross product. We know how to do cross products, right? And didn't I say that a lot of problems could be used by setting up a proportion and solving? So maybe this might be one of them. Let's check and see. So if we do 30 times x, we're going to get 30x. And if we do 25 times 37.20, you're going to get 930. And then if you divide both sides by 30, you're going to get 31. That is the correct answer. So Robertson's method technically would work on the black calculator. Do you know why it doesn't work on this calculator? Because what this one is doing, is it's following the order of operations. So the order of operations here is stating, oh, you want to do 24%. It's going to change that to a decimal first. So now it's just saying, oh, you just want to do 25 plus 24% as a decimal, which is 0.24. That's why they got 25.24. On this calculator, what you actually would have to do instead is a third method, which is to take the price and multiply it by 1.24, and you'll get 31. The reason why 1.24 is because it's saying, hey, I'm going to incorporate that 25, plus I'm going to incorporate 24% of that 25. Remember, what keyword does of mean that we're doing? What operation? Multiplication. So I'm doing 25, which is the multiplying it by 1, plus I'm doing the 24% of 25, and then calculating it together. So there's different methods. What do you think is the easiest one to set it up? As all time? Proportion. Okay? Hurry up. I see that. I see she's doing the bathroom dance. All right. Let's take a look at another problem. I want you to try this one on your own. Oh my goodness, she's making us actually do work. I'm trying to go ahead and do enough notes. Shh, quiet. I mean, I could give you the assignment instead, and then you would have homework tonight. Or you could do the notes and not have the homework tonight. There you go. That's what I thought. So June's been saving. Yep, for a video game. No, she's got a better life than that. Okay, last year it cost her $28. This year it's going to cost $36. Shh. What is the percent of change? I'm going to test your different rounding skills. Round to the 100th this time. I want you to round to the 100th. You know you're being recorded. Shh. All right, raise your hand. Tell me, what did you get for the percent of change? If June had goals of getting a video game, it was $28 last year. It's $36 this year. What's the percent of change to the nearest hundredth? Cameron? That's the nearest tenth. I want the hundredth. 28.57. Very good. So 28.57. So if you've got your original price, the game originally cost $28. It's now going to cost $36. So the price went up. It increased. We're going to take the 36. We're going to subtract the 28. We're going to divide by the 28 and multiply by the 100. When we subtract 36 minus the 28, that's going to give you 8. So you'll have 8 divided by 28, and then you're going to multiply that by 100. That's going to give you this long drawn out decimal of like 28.5714, and it's going to keep going on and on and on. So you need to estimate it because I want to the nearest hundredth. That's 2 decimal places. So it's going to be 28.57%, and that was an increase because it was positive. It went up in price. Okay? Are there any questions? All right, tomorrow we will work on some practice problems for the percent of change. So instead of you having homework, you're going to do an in-class assignment. Tonight, you have an extra credit opportunity on Prodigy Game. Get on the Prodigy Game, and there's 20 questions. It is only open tonight. It shuts down at midnight. So if you are wanting to do it for an extra credit boost right now, that's your opportunity. Whole thing. 20 questions. Then it would give you a bonus.